Today we're going to start log properties. So there's going to be quite a bit to write down. So make sure you have your 3 boxes ready. So our first property is right here. A to the power of log base A of m is equal to m. Effectively, when the base of the exponent and the base of the log match, they cancel and you're left with the m right here. And I'm going to call this the sandwich property. And that's because it kind of creates a sandwich, right? This A and this A, same value, kind of sandwich the log. So to use it's pretty simple. If you look right here, I'm in that scenario, 2 and 2 match, cross it out, you're left with pi. Now it seems pretty mysterious, so we need to explain what's actually happening here. So the example I'd give you would be this. 2 to the power of log base 2 of 8. Now, using the property, we can see this is 8. But let's really talk about it. If you look at this thing right here, log base 2 of 8, well, you know that number. 2 to what power makes 8? Well, that would be 3. And of course, that is 8. So I can see this by working it out. It definitely works. Now, conceptually, if you think about it, this number, whatever it is, let's say it was a harder number. Let's say it was like 7. We clearly can't do this in our head. But this represents the number that when you put it onto a 2, meaning the exponent right here, you get 7, because that's what this means. Log base 2 of 7, if you convert it to exponential, it's this. It represents this x, and if you put it on a 2, you get the number 7. So that's going to be the conceptual way to understand why it's 7. If you're still kind of stuck on this, we can talk about it in class further, but for now, just mechanically know that when they match, you cross them out, you're left with the same value. The second property, this is kind of a cool one. Log base A b to the x, that's equal to x log base A b. So I call this the hairball property. And I actually learned that from Mr. Rubash. I like this name. First time I saw him teach it, he used this, and I really like the visual this creates. He calls it a hairball because you imagine this is like a cat. This thing can like shoot out to the front of the log, much like a cat would shoot out a hairball, and it moves it to the coefficient. And just like a cat, sometimes they eat hairballs and they can actually go back to the exponent. So essentially, this property allows you to move the exponent from the coefficient to the exponent freely. Okay, let's try this example. Notice how you don't need the sandwich property, or you even can't use it, because to use a sandwich property, it has to be in this form, meaning a log and the exponent. So we'll make a note here. Log as an exponent. That's a big clue. You got to use a sandwich property. And I can see here that is not happening, which means I can use my hairball property. So grab our exponent. Let's move it. Negative root 2. And now look how easy this problem becomes. This part right here, well, that's just 1, because 0.2 to the 1 would make 0.2. And that's just negative root 2. And we're done. Now let's go to our last example here. Notice how we, again, can't use the sandwich because there's no log in the exponent. So instead, we're going to hairball it. Kt times natural log e. Recall that natural log e is like saying log base e of e, which means natural log e is simply 1. So you definitely want to highlight that in your notes. So that's just kt times 1. The answer is kt. Okay, the next properties we're going to go over. This one is called the sum and difference property. So you're going to write log base a of m plus log base a of n is equal to log base a m times n. And conversely, if I make it subtraction, you get log base a of m divided by n. So notice how addition is linked to multiplication, subtraction is linked to division. Now the reason this is because logs are exponents. That's the reason these properties work the way they do. Because when you're adding exponents together, what you're really doing is you're multiplying the actual numbers. And if you're subtracting exponents, you're really dividing those two numbers. So that's why these properties operate the way they do. And to use them is pretty straightforward. I can see that's adding, so that's log base 4, 8 times 2, log base 4 of 16, and that would be 4 to what power makes 16? The answer is 2. Next one, log base 4 of 8 minus log base 4 of 2. Notice how these bases match, so you need the bases to match here, so that's important. Notice how all these bases match. Bases must match. So 8 over 2 is obviously 4, and that would be 1. We can do a couple more now. Let's look at this one here. So this one, I'm going to use the hairball. That's just 10 log base 2 of 2. And then I know that's 1. The answer is 10. And now this problem kind of explains why the hairball property works. Because if I think about this problem, this is really log of base 2, 2 times 2 times 2, dot, 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 dot. Which means I could really think of this using our addition property like this. Just adding a whole bunch of logs. And notice how there would be 10 of these. Which means this is effectively 10 log base 2 of 2, which is 10. But in order to avoid this, we use a hairball property just to save ourselves time, and notice how you get the same exact answer much more quickly. Okay, here I can see this is clearly the sandwich property. So these cancel, x squared, pretty easy. Now for the last two, let's do this one first. So you look at this one and it's clear that we want to use the sandwich property because I can see that there's a log in the exponent. However, these don't match. So we gotta do a little bit of playing around the properties. I know 9 is 3 squared, and then I'm going to hairball that 2 here. So now I have e squared log, actually I'll write it a little bit nicer, e then 2 log base e squared 3. And then because this is all an exponent, I can put parentheses here because that'd be the same thing. And now I can see that the bases match and cross it out. Answer is 3. So that's kind of an advanced problem because ultimately we did have to use the sandwich property here, but we had to use the hairball property first. It's a pretty cool problem. Now for the last one, you'll notice here, this is a unique problem because the bases don't match and we're multiplying. In this situation, there is one last property that logarithms have that's very helpful. It's called the change of base property. So this property is useful whenever you want to mess with the base of a log. And the property is like this. You have some generic log, log base a of b, that's equal to log base x of b over log base x of a. Notice how the b goes up top, a goes on bottom. This x can be whatever you want, right? Any number. But what people use the most is this, log b over log a, meaning a common log. a base of 10. So that's what people do the most with this thing. So I'll put a little arrow there, and I'm going to note most common use. And I'm going to highlight it for you guys right here, make it a little bit nicer. So we're going to try it here. This is log base 4 over log base 3 times log base 9 over log base 2. Again, I'm using base 10 just because it's easier. Now we're going to rewrite a few things. 4 is 2 squared. 9 is 3 squared. Now let's hairball these. So hairball, hairball, and look at what happens. The logs all drop out, and we're left with a really clean answer of 4. Now for the final examples, this says suppose that natural log 2 equals A, natural log 3 equals B. Rewrite in terms of A and B. So it looks pretty crazy, actually really simple. Natural log 12, look at the 12 and write it in terms of 2 and 3. So for example, I'm going to write natural log of 2 times 2 times 3, meaning I'm breaking up 12 into factors of 2 and 3. Now I'm going to separate it using a log property. I use addition because we're multiplying, and now I can use A and B. That's A plus B, or 2A plus B. That's our answer. Let's try this one. This is a little bit trickier. I see the root, a fifth root, so I'm going to write it as 6 to the 1/5, and I want to hairball that. Now it's a little bit easier. So 1/5, I know natural log 6, that would be natural log 2 plus natural log 3, because 2 times 3 would make 6, which means our answer is 1/5 A plus 1/5 B. And we are done. So good luck on the questions, and let me know if anything comes up.